Okay, so we need to show they gave us that AP is a tangent. AP is a tangent to the circle. We need to prove that BA is parallel to OD. That's what we need to prove, that these two lines are parallel. Okay, so if you think about it, we need to try to prove that this angle here is corresponding with this angle. If we can show that angle B is equal to O1, if we can show that, then we can say therefore the lines are parallel. So that's an option. Another option is to look at the Z. If we can show that A3 is equal to O2, then it makes a Z. Then you can also say, okay, they are alternating, so it must be parallel lines. Another option is to show co-interior angles. So if we can show that this angle here plus this angle is 180, then we can also say it's, so there's a lot of options. So the one way you can do it is you can prove that these two triangles are congruent. Obviously, this side is a common side, OE is a common side, AE is equal to EC, and OA is equal to OC because it's the radii. So we can prove that these two triangles are congruent, okay? And if they're congruent, it means that O2 is equal to O1, okay? And think about it, AC goes to B and AC goes to O, okay? So obviously we know that if we say this is X, then we know this angle must be 2X, okay? Because it's the angle at the center. Goes that way, goes this way, okay? So if we call this angle X, we can say this is 2X. Then we can say that O1 is equal to O2, okay, because it's congruent, which means they're both X. X and X is 2X and X. So then we can say, therefore, O1 is X, which is equal to B, which is X. Therefore, the lines are parallel. But that's long, because it's just 4 marks. But that's an option. We can prove congruency, then we can say, therefore, O1 is equal to O2. So we can say, if we say O1 is X, then O2 is X, which means this is 2X. But then we know that B is equal to X, because it's the angle at the circumference, okay, angle at the center. So therefore, B will be equal to O1. And that means they're corresponding, which means BA is parallel to OD. But that's a long method, like I say. I think a shorter method would be to try to show that we know this angle here is 90. We know that, okay? It's the angle on the diameter. So if we can show that this angle is also 90, then we can say, so it's co-interior angles. So then the lines are parallel. So I think that's going to be a shorter way. So now we must try to think, how can we show that E1 is 90? Well, actually, you can use the same method. You can say if these two triangles are congruent, then obviously E1 is equal to E2. So they must both be 90, okay? But then I think another option might be to show that this is a kite. Because if it's a kite, then we can say, well, if it's a kite, it means the diagonals bisect the one diagonal, bisects the other one perpendicularly. Okay, but they didn't say that DC is a tangent. It would have helped a lot if they just said DC is a tangent. Because then you can say if it's a tangent, then it's perpendicular to the radius, which means it's 90 there. And that one is 90, and then you could have used actually the fact that this is a cyclic quadrilateral. That would have been maybe even better, because then A1 would have been equal to O1, okay, from chord DC, this way and that way. And we know that A1 is equal to B, okay, because it's the tangent and the chord. Goes this way. So A1 is equal to B, and then if you say, but O1 is equal to B, because of the chord DC, then O1 must be. So there were so many options actually. But that was only if they said that DC is a tangent. They didn't. So I think from everything I said, I think our best option is to start by saying BAC is equal to 90 degrees. Angle on diameter. Okay, so this angle is 90. And then I think we should probably just, if we couldn't prove that this is a kite, we can probably, if we try hard enough, I'm sure we can prove it's a kite. But let's just now say that use the congruency. Okay. So we can say that if we look at the two triangles in triangle AOE, and let's just put in triangle, and triangle COE, first of all, we can say that OC is equal to OA, radii. And secondly, we can say that OE is a common line. Okay, common line. And then thirdly, we can say that AE is equal to EC, because it's given. Okay, therefore, triangle AOE is congruent to triangle COE, side, 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 and therefore E1 must be equal to E2, and they must both then be equal to 90 degrees because it's a straight line. Okay, so then we can say therefore BAC plus E1 is equal to 180, and therefore AB or BA is parallel to OD, and our reason co-interior angles. Okay, so that maybe that wasn't the best option, but at least we got there. Okay, normally you just try to get to the answer, even if you take a longer method, you just try to get there. Okay, so now the second question was, we must prove that AOCD is a cyclic quadrilateral. Okay, so now we actually found out a lot already with the first question. Okay, but I think what we can do here is we can say that A1 is equal to B. Okay, because it's the tangent chord theorem. Okay, it goes this way. But now, from the fact that we showed that these two triangles are congruent, okay, we obviously know that those two angles are equal. This angle is equal to this angle, okay, because we proved congruency. So we know these two angles are equal. Okay, so if we can show now that B is equal to O1, we already know A1 is equal to B, but if we can now show that but we know it now, that O1 is equal to B because we showed they're parallel. So they're all corresponding angles. Remember, we actually decided to use the 90 degrees to show that those two lines are parallel. But now we can just say A1 is equal to B. Okay, our reason, tangent AD and chord AC. Chord AC. Okay, let me just draw a line there. So we can say that this A1 is equal to B. There's the tangent AD, or you can call it AP, and then there's the chord AC that goes this way. So this one is equal to this one. But we can also say that O1 is equal to B. Okay, we can also say O1 is equal to B because it's the corresponding angles. Because we showed that AB is parallel to OD. So because they're parallel, obviously we can then say that those two angles are equal, which means A1 is equal to O1. So we can say, therefore, A1 is equal to O1. Okay, and if they are equal, if that one is equal to that one, then this must be a cyclic quadrilateral because they both start at DC. DC goes this way, DC goes that way. So we can make our conclusion. Therefore, AOCD is a cyclic quadrilateral. We can say it now. It has to be a cyclic quadrilateral. And then our reason is DC, chord DC subtends equal angles. Chord DC subtends equal angles. Okay.